This is a video about photometry. Today we will discuss the topic transformation of your measurements. This is the viewer of the ASTAP program. First, we have to open the Stack menu and we have to go to the Photometry tab. I have loaded about 60 images of a cluster called M67. It contains several standard stars. If you click on a file, it is displayed. This cluster is M67. The green annotated stars are reference stars and the yellow ones are a few variable stars. But they are not of interest today. The image exposure is 10 seconds. Longer exposures are practical with the SeeStar telescope. So what I will first do is to split the raw images into red, green and blue channel images. Then we will stack the images again and then we have a longer exposure time. So what to do is to select all images using the pop-up submenu. After selecting all, you can select, extract green, blue, red of the selected raw files. We're talking here about raw files. Okay, there we go. I will now pause the video since it takes some time. Separation is ready. We have now 180 images. They look a little different. In the viewer you can still see the original one-shot color image. If you click on one of the new files you can see that the background is more equal. But the resolution has gone down to 540 × 960 pixels. The exposure time is still 10 seconds. So the next step to do is to stack the images in groups of, let's say, 10. I call up again the pop-up menu. And with the right mouse can I select Stack all files in groups mode average. We select 10 images for each group. You can see immediately that the files are sorted on filter. Sorted on blue, green and red. Secondly, it is sorted on date. Again, I will pause the video till it's finished. Stacking in groups is now ready. The exposure time is now 100 seconds. So each time 10 images are stacked to 1. If we view an image, we can see that the signal to noise ratio is better. So we can go deeper. We can check how deep the image goes. I can do that by tools. But let's first solve the images. Select first all images. And select Refresh Astrometric Solutions. Let's now check how deep this image goes. Go to Tools. Select Magnitude Measured Annotation. The image goes down to magnitude 14.27 for a signal to noise ratio of 7. Next step is to measure the images. For this we have to press the play button. It's this button. So when I press the play button, the program goes through all the images and measures the annotated stars. Another thing to do is to check the settings. For photometry, do not measure fainter than magnitude 12. So I select magnitude 11. Make sure that there are no stars which are too faint. OK. Press now the play button. You can see on the right side of the list that they are filled with star data. This area is now filled with data. We see the magnitudes, signal to noise ratio and the flux. In principle, we are only interested in the standard stars. The abbreviation starts with 000. Next step is to press the transformation button. Select the normal mode. Sloan should be unchecked. Press calculate. You can see the difference between the color, BV capital, and the measured BV. And you can see that's a linear relation. So this is the error you get by the star color. There are 6 coefficients and curves available. Sometimes there are outliers, like this red dot. Filtering of outliers is done by standard deviation limit of 2. So these are 2 outliers outside the purple limit. These are the transformation coefficients to be used for the transformation of the measurements. We have to save it. We go now to the report windows to test the transformation. So I call up the report window by pushing this button. There are 3 areas. The area for the variables is not interesting today. We have the comparison stars and we have the check star. Now for the SeeStar, it's normally better to select a few comparison stars. Adapt sorting if required. Six comparison stars selected and we have 1 check star. This area is very important. It reports the measured magnitude minus the documented magnitude, and it's for the blue channel 0.397. For the versus channel. So that's green. The error is typically lower. Normally the passband of the green channel is very similar to a Johnson V filter. Therefore the versus error is typically small. For blue it is typically larger. For star 901, the blue error untransformed is 0.397. If the transformation is applied, the error is 0.46. The last value, the curve standard deviation, is today not so interesting. So you can see that the B-B error after transformation is much lower. For the V channel, it's about halved. The transformation doesn't always work well, especially when the star becomes too faint. But we can test it. We will check now another check star 862. For star 862, the blue channel error is reduced significantly. Same for the V and red channel. Let's try the next star. We're comparing now star 863 using 6 comparison stars as reference. And again, you can see that the error for blue is mostly gone. For V, it's more or less the same. Let's check some other stars. Let's take a faint star. You can see that the error for blue is doubled, so it's worse. And for the V, it's almost the same. This is due to the blue magnitude being fainter than magnitude 12. The reference magnitude of this star is 12.68, too faint. This is too faint for the SeeStar telescope. So normally you should avoid to measure any star fainter than magnitude 12. For this star, the blue magnitude is brighter. Let's see the results. For this star, the error is still smaller. In general, the transformation improves the values for the B magnitude. The V, the improvement is small or none. Okay, let's now try to transform some variable measurements. Clear the tab with the Clear button and browse for other files. These are stacked images of W-UMA. Let's first measure them. We'll press the play button and pause the video. It's almost ready. We're ready. In the list, all the measured data is collected on the right side. Then we press the report button. This is a nice variable. Nice curve. Only variable star W-UMA and 2 other stars are available. Visible here. The yellow annotated star is the variable, and these are the 2 stars we can use as comparison or check star. Report transformation will be applied by checkmarking this option. The transformation of the check star is for this window only. It's never reported. It's just to check if the transformation works. So we can see here that the blue channel error is reduced to 50%. And for the V, it's a little reduced. And for red, it's a little higher. so there's mainly gain for the blue channel. Because we don't have any other star, we cannot check it. So we'll generate the report, save it and have look to the report. In the report, the transformation coefficients are recorded. The transformation field has changed to yes. The TR values are reported as R. TB values are reported B, and the correction calculation is indicated in the comments. This is the correction calculation for the R channel. And it also reports that the original filter is TR. It also reports the aperture and the annulus used. You can also generate a report without transformation. Just uncheck this one and report to file. And this changes to no. This is the default situation. And there is nothing in the comments about transformation. Okay, I hope this is clear. Again, remember, don't try to report any star which is fainter than 12. Else the error will be pretty large. So measure only stars which are brighter than magnitude 12. Okay, that's it for today. Thanks for your attention.